Hello all and welcome to Rust for C Engineers series. Today we are exploring the first program in Rust, that is the Hello World program. So before learning a new programming language, the first program is traditionally a Hello World program, right? The purpose is not just to teach programming but also to verify that the development environment is installed correctly. Okay, so if the program compiles fine, links fine, and runs successfully, it basically confirms that the compiler, libraries, and the execution environment are working as expected. Okay, and once the setup is verified, then the attention can then move to the language itself. So if you see here, we have two files. Okay, one is a .c file and another is .rs file. Okay, all source code in C files end with .c extension, as we already know, and in case of Rust it ends with .rs. .rs means Rust source. Okay, so here we are going to compare syntax differences and also design differences between both the languages. So here if you see, the right hand side is C code and left hand side is Rust code. Okay, so one common thing between both the languages is main is the entry point in both the languages. So in case of C, it starts with void or starts with the return type and then function name. In case of Rust, it starts with fn. Fn means function. The keyword fn means function main. Okay, all the functions in Rust start with fn keyword. So here if you observe, we have a printf statement which simply prints hello world, right? So this printf is a library call and called at runtime. Okay, however, if you see this, observe println and exclamatory mark. So in case of Rust, exclamatory mark definitely seems unusual for C programmers first time when they are seeing this, right? Exclamatory mark means it's a macro. So println and exclamatory mark, this is a macro. So unlike a function, macro basically runs during compilation time and generates Rust code. So this is one of the design differences between C and Rust. Okay, so why did Rust choose this design difference? Basically it wanted to move many checks from runtime to compilation time. So like validating format strings, validating the arguments, right? So all of this it wanted to do at compilation time to avoid formatting errors. Okay. The next one is that, so printf needs stdio.h, right? So this is present in this standard library. So in case of Rust, if you observe, there are no hash include directives at all. Okay, so that means that Rust automatically makes commonly available items from standard library. So for example, println can be directly called without needing to include any libraries at all. Okay, so as the course progresses, we will see that if you want additional functionality in Rust, we have something called use keyword. With that use keyword, we can import additional functionality. Okay, that we don't need to worry about it now. Okay, and absence of header files in Rust is basically one of the Rust productivity improvements. That's also another design difference. So instead of maintaining separate declarations and separate implementations, each module contains a single authoritative definition. And how is it helpful? It basically allows compiler to directly work with the actual source code itself. So what is one of the disadvantage of header files? For larger projects, I think many of us might have had this experience that while rewriting or reusing code, all the header files from one file gets copied to another one, right? Whether it's required or not, they're all copied, right? So, and for that, what we need to do is inside the header files, we include something called include guards, like hash if not defined, then only define, right? So we do want to avoid duplicate declarations in C, so we include guards, right? So that's not required here in case of Rust. In case of Rust, basically absence of header files simplifies the project organization and reduces maintenance effort. Okay, that's another thing. And the next one is about the return type. Okay, so the return type here in this case is, in case of C, it's void. Void means absence of return type. Okay, so in case of Rust, so how do we mention a return type? By saying, arrow and like this. So this means basically default. It's called a unit type. Okay, unit type also is very similar to void, but there are a lot of differences. We are going to cover about this when we deal with functions in detail. Okay, so for now, just know that if any function in Rust is not returning anything, it means it's returning a unit type. Okay, for now, we do not need to learn about this. Let's compile the programs. Let's compile the C program first. Let's run the C program first. It printed the first hello world, right? Now let's compile the Rust program. So how do we do? We say rustc, Rust compiler, and hello rust.rs. Okay, it created this executable. We'll run this. And it printed the first hello world statement. Okay, so now because we are writing standalone programs, we can use rustc directly, Rust compiler and the input file name. But however, rustaceans means people who have learned Rust are called rustaceans. They love cargo because cargo is the standard way of building. Okay, in next video we are going to learn completely about cargo. Again, it's a development workflow, but it's very important to learn. But however, we can still use rustc for all the standalone programs that we are going to write. Okay, until we do multi files and project organization. Okay, till then you can simply do rustc and filename.rs to compile and understand the Rust concepts. Okay. Okay, and another thing today, what did we do? We just learned that, smallest Rust program already demonstrated many things. Okay, first we validated the development environment is set up. We also saw functions, we saw macros, we saw blocks, curly braces, and then also statements, printf and println, right? I think that's the fun fact.